Check 1, 2. Check 1, 2. Check 1, 2. Check 1, 2. That's not good. Check 1, 2. Check 1, 2. Okay. Let's hope for the best. Okay. Thank you for your patience. Number one, how do I want you to do this? What do we start with? Max, what do we start with?
So we go one of two ways. I
Oh,
went like a more kind of unconventional, like straight to it way.
okay.
So three like x coordinates, 0, 1, 2. And I plugged them in for x, and I like based on that kind of graph it.
Okay. So you're making like a T-chart.
Yeah.
Okay, so that's one way that will always get you there.
Second way is taking the graph of e to the power of x, the parent graph of that.
Okay.
Moving it to the right by 1, horizontally stretching it by 2.
Thank you for reminding us that is what I expect for you to take the parent function and then to transform that appropriately. Let me make sure I'm sharing the right thing here. Am I sharing this? Yes, I am. Okay. Okay, and for the parent function, how many points do I want to see for this graph? 3. Starting from left to right, I want x equals, from left to right, I want x equals -1, 0, and 1. So let's just make sure we're okay with these. Let's do the easy one first, shall we? The easy one would be, yeah, x equals 0, which gives an output of 1. I think it's just 1, isn't it? 0. If x equals 0, I start from 0. The next easiest one would be, I think 1's a little bit easier than -1, isn't it? In my opinion. When I plug in a 1, out comes a, what number? I want exact. E. Do you know what E is? About 2.7. How are you supposed to know that? Because we talked about it in class. And maybe you remember from last year. But it's something you should know. Just like pi is approximately 3.14. I expect you to know that E is about 2.7, and that's all you need to know. Does anyone remember the other numbers after 2.7? 1828. And after that, 1828 again. It happens to repeat 2 times. And that's it. That's no easy repetition that I should know. So where should I mark the y value? How about right here? And I'll mark that E. And there's a point right there. So that's exact. And if it were on graph paper, that would be somewhere between 2 and 3, a little bit closer to 2. And the other point, when you plug in a -1, the output is 1 over E, which is approximately
1.4. It's like 1.
1 over E is approximately 1/3. I think that's a pretty common. It's really 1 over 2.7, but 1/3. 1/3 is approximate. And I'll mark that over here, 1 over E. Okay. So there we go. So like this, are we good with that?
No.
Now this should make you very angry.
It does make me.
Yeah.
Crossed death.
You've crossed the line. Oh. Literally. Exactly. I've really crossed the line this time, Mr. Lieberman. Okay, there we go. So that's the parent function. Would you please show me, let's go from left to right. Like, what is this gonna do to that parent function? So it's horizontal, it grabs it and stretches it by a factor of 2 is what we say. And then of course this over here says we're going to
Right.
move it to the right. Is it 1?
1 unit.
Is it 1 unit?
Yes.
It's not 1. It's not one, and that's a one, yeah, by the way, it's not one. It's a factor with the 1/2. We have to put in transformation form. You can have a -1 there, but the transformation is hidden. So I'm going to rewrite that as e to the 1/2 times the quantity of x. Does that work? Is this the same thing? So it's actually being moved 2 to the right. Yes.
Whenever we have a horizontal stretch or compression and a vertical, then we should put that.
Always, yes, for
Oh,
sure.
wait, not. Or like the.
Oh, the
Yeah,
horizontal.
anything horizontal, there's two.
Yeah, if there's any sort of coefficient here, factor that out. Yeah, if there's a coefficient. Yeah.
So we'd say right back to. Or.
And then, yeah, to the right too. Okay, so we're going to take these 3 points, do what we just said. Which one should we do first? The stretch or the shift? Multiplication always comes before addition, subtraction. So what's going to happen to the 0, 1? The stretch does nothing to it, right? Because it's right in the middle. It's a 0, so nothing happens to that. But it does move to the right too. So it goes to here. Are we comfortable with that? Let's just make sure that point is right. How can I check to make sure that point's right? Let's plug it into the original. If you plug in a 2, do you get a 1?
Yes.
Al, what do you think when you plug into it? What works? Works out?
Yeah, you get a 1.
You get a 1? Okay. Okay. Next point was 1 comma e. Now that's going to become 2 comma e, which becomes 4 comma e. Does that make sense? Remember this, so people at home can see. This space here is doubled, right? We're stretching it by a factor of 2. So it becomes 2 comma e temporarily, and then it's 2 to the right. So 4 comma e. I'll put my e right there. How can I check to make sure that's right? Let's plug it in. Okay, plug in 4. Does it work? Does it work? E is what comes out. Plug in a 4. Notice we're not just finding random x values to plug in, like Max's first idea with that. Like you could plug these things in. We're taking the points that we know and just moving them where we want them to go. And the last one started at x equals -1, and then what happened to it? It temporarily moved to -2, and then 2 to the right. As it to 0. So 0 comma 1 over e. Do you have those 3 points already? And you can check by plugging in 0. I think you're gonna get 1 over e. Yep, 1 over e. Cool. What happens to the asymptote? Stays the same. Does the asymptote ever move? When, in what cases? If there's a translation, right? A vertical translation. But horizontal translation is just going to keep it exactly where it is. Right. Good. Okay. Max, thank you for getting us started on the right foot there. Appreciate it. I need some help for number 2. Specifically from Kayla. What do I do? How do I show that these two are inverses of one another? So like find g of h of x and h of g of x. You're saying that both of these have to equal equal x. Do we agree? Okay. Did it work out?
Yeah.
Do you really have to do both? Yeah. If you're showing that they're inverses, you want to show that both are inverses of one another. So yes. Do you mind if I don't do that? Is that okay? Yes, Haley?
Sorry, I have a question for the first one. Say
Huh?
you didn't do it with like using the paragraph, you just plugged in values.
Mm.
Would that be like wrong? Because like you wouldn't get maybe like the exact points that you would have gotten from like -1 and 1, 0. Like did you get your work wrong?
I can't say it's wrong, but you might be missing stuff. And it's definitely too much little calculations. You're missing one of the big concepts. But as far as taking off. Like if you plug in 0, 1, 2, 3 or something like that and get some values, it would be right. It would take too long and there's a chance of error is all I would be afraid of. But whatever you do, there's chance of error unless you're doing it right. So be careful. Now, if it said to use transformations to graph it, then it would be wrong. Which could happen. So let's just take note of where we are. This is not our class. This is our class. Okay, so we did this last time, and today we're doing inverses of exponential functions. And today there's going to be one page from the homework packet because that's all that's left. And then there will be a Pearson assignment, just so you know. Both fairly short, which means we're coming to the end of our units. So let's do this. Oh, I'm sorry. I need to do the last part of the warm up. I'm so sorry. Please graph the inverse of y equals e to the x. Yeah, please graph it. No, e to the x looks like the graph the inverse of it. Make sure your neighbor is doing okay with this. Whenever you're ready.
Wait, neighbor, I'm kind of confused. How do we get more space? Wait, but don't you have to turn it into, you're making it inverse first, right? And you have to do it how
You can just graph it.
Just graph
You don't have to make an equation.
Oh,
Just graph it.
it's definitely upside down. It's flipped over. Oh, yeah, they flip over the origin, so it's gonna be.
I'm a little confused to like where the.
Do you want some help with this?
Oh, you're.
I'll give you another 15 seconds.
Yeah.
This is, wait, hold on. Oh.
Let's go to the
I think it's really. Where we get this?
Remember.
So I'm just thinking.
This.
Yes.
Okay. Ready or not, let's do this because if you haven't finished it, you may be thinking too hard.
I was thinking.
Now I'm going to take this e to the x. I'm going to start here. If I get everyone's attention, please, I'm going to point out that the nature of this function starts like we kind of look at it from here, right? We're looking along the x-axis going from left to right. Yes. And then the graph climbs its way up the y-axis, doesn't it? That's what's happening. So if we want to graph the inverse of it, the green goes from being in the x-axis to going on the y-axis, going which direction? It's up, right? From negative to positive. So go in this direction. And the red arrows, they were going up. Now, which direction should they be going? to the right, right? The X's and Y's are flipped. So it was the Y's going up. Now it's the X's going up. Just kind of the trend of the graph here. And the inverse is really just the same shape, isn't it? It's just the relations are opposite. So when I graph this, I'm going to start at the low G's where the value is very small. Does this make sense? I'm starting with that. And then I'm going to do exactly what it does for my exponential function. It's exactly the same thing, isn't it? Would you please name 3 points on that graph if you haven't done it already?
Oh, wait, so it's one over. And one,
Why is that?
two.
So the points, well, I want to hear from one of you. What are some of the points that we know? L.
I said,
So, oh, 1 over e comma negative 1. Okay, do we agree with that?
Yeah. Good one. Oh, yeah.
1, 0.
And 1, 0. Okay. And e comma 1. This is not to scale, but I hope it makes sense that these are 3 points. It could be coordinates on our inverse graph. And you got those, of course, from the regular graph. We knew the other 3, right? Negative 1 comma 1 over e 0, 1. It's just the nature of inverse functions. Thank you, Al. Speaker changed. Hopefully people can hear me now. But that's not how we write functions. We want it to be a function of x, so we rewrite that as log base e of x equals y. This could go away now. I don't need that. Okay. And log base e is just the same thing as saying natural log or ln of x. So ln of x. Y equals ln of x. So this is not the most recent parent function that you need to know. But really, it's just e to the x, isn't it? It's just e to the x.
What graph looks like.
This is what an ln graph looks like. But let's talk more generally. Let's talk about just y equals log base b of x. So would you check with your neighbor if see if they remember what the restrictions on b are for logarithms?
Can't be 0. Yeah.
Check 1, 2. Okay, so restrictions on b. Jonas is not here. Shiv,
Oh, yeah, so B has to be greater than 0 and B can be greater than 1.
do we agree with this? Nicely done. Yeah, b has to be greater than 0 and b cannot equal 1. So this graph that we have here is log base e. Can you imagine what other bases would look like? Like log base 2 or log base 5? Discuss with your neighbor what would happen as the base changes.
The base is higher, I guess.
Did you get it? You see what changes? Specifically the point
To
e comma 1 changes to b comma 1, and b could be
100.
we like 100. Let's say it's greater than 1. It's going to look like this. Does this make sense? It's going to go through b comma 1.
Then it gets 1.
So this is if b is greater than 1. But b could also be The word is between 0 and 1, which makes perfect sense on the graph, doesn't it? Because we have that 1 right there in the middle. So if b is between 0 and 1, do you see what the graph would look like? We still have that 1 right there. What's that? Can you trace what you think it might be on the whiteboard in front of you? You just trace it with your marker finger. Like, is it a squiggle? Yeah, it's just gonna come down like this. Right, this is still b comma 1. But b is between 0 and 1. Yes.
So that graph on the left, the bottom left is what it would look like.
Exactly. Yeah, it would be wider than well, it depends what you're comparing it to. It would be wider than like if this were 4, it'd be wider than 3.
Yeah, is the vertical asymptote always zero?
Oh, good question. Is the vertical asymptote always 0? Well, I guess the analogous question is for exponentials, is the horizontal asymptote always y equals 0?
But no, unless there's a transfer.
Unless it's a transformation. So without transformation, exponentials, the horizontal asymptote is y equals 0, and for logarithms, it's always x equals 0. Because they're inverses, exactly. So they share the same properties. Okay, now let's get back to are we good with these? I do need you to have this one specifically, right? That's the more important one than if b is between -1, 0 and 1. Okay, to the packet. Did I go too quickly? I am missing one point here. What's the point that I'm missing? The 0 one's there. 1 over v comma -1. It's also on this graph. So I'll put that just to be complete. Okay, enough of that. Okay, so general form of a logarithmic function, you can see here, a times log base b of x. A serves as, what is it? It's a leading coefficient. That's more for polynomials, but in terms of like just our concepts here, a is inside the function or outside? Outside. Outside, that's how we know it is. Oh, vertical. Yeah, vertical stretch or dilation, depending on the magnitude of it. Okay. Taking a look at this, you recognize what kind of function it is? Are you sure it's exponential? Very much so. It's very definitely exponential. Yeah. But we just have to make sure the x's are increasing in a standard pace consistently. So when you see these, is this also exponential? Right, we switched the x's and y's, so this is no longer exponential. This is logarithmic. Okay, so here's 4 for you to try. Go for it. Did you finish?
Yes.
Okay, for A, I'm looking for what do you think it is and why? Haley, what do you think for A? Nicely said. Thank you. Oliver, B.
Yeah, I got one.
Thank you very much. Emma, C.
Both the X and the Y values, how much context.
Exactly. So there's some sort of ratio, there's some sort of relationship, but it's neither directly exponential nor logarithmic, so we're going to say neither. This. So good. And lastly, D. Una. Perfect. Easy. Moving on. Um, let's just do example 4. You're reading it, you're thinking about it, discussing it.
Miracle always includes X. That's what that one is. I don't, I don't know. Yeah.
Bless you. Did you get it?
Yeah.
Okay, I'd like to hear from someone specifically. Miley, can you help us out with this, please? Okay. So you don't have to calculate for A or anything like that? Okay, good. Thank you. That'd be a huge waste of time. And thank you for mentioning the slope. Did we all think that for this? When you see the words average rate of change, that's exactly what it is. It's a slope. So you just did. Are we good? Thank you. Very nicely done. Yay. Yeah, so this is a packet. I know. We completed the A portion of unit 2. There's a B. I think there might be a C. I'm not sure. So before homework though, there's something I want to do with you guys. Let me stop the video.